Okay, everybody, so what I'm going to try and do is give you a little breakdown of this. I'm hoping that you've watched some of the other videos, but here we go. So quickly through some of the things that you've got to be able to do. So we have to be able to do square roots, cube roots, or fourth roots of stuff like this. So if I have, maybe something like this, 54x to the 6th, y to the 8th, and I want to simplify that. Cube root means I need triplets, so I would do 6 times 9, and 9 is 3 times 3, and 6 is 2 times 3, and you can see that I have triplet 3s. I need 3 of the same factors to be able to get it out of a cube root. That's kind of what that means. So I'm going to pull a 3 out. Cube root's still there, and this little sucker right here doesn't have anything, so it's got to go back in. X to the 6th is really 6 x's, or 2 sets of triplets. So I can pull an x squared out, and there's nothing left inside here. Again, because I needed 1, 2, 3, 4, 5. I had 6 of them. There's one set of triplets. There's another set of triplets. I have 2 on the outside that are real. Y to the 8th gives me a y squared on the outside and a y squared on the inside. This y squared represents 2 sets of triplets from the inside, and that is that one. On your second test right now, you have to be able to do multiplication with this stuff. So let's say that I've got 4 square roots of 2x times 6 square roots of 18x to the 5th, y to the 7th. Well, what I'm going to do is I'm going to multiply these two things together, and I get 24 square roots of 36x to the 6th, y to the 7th. Square root of 36 is a 6 and a 6, so there's your twin 6's, and that gets to come out. And 6 times 24 is 144. And then square roots. X to the 6th, well, there's 3 sets of twins in there, so there's an x cubed that gets to come out, and no x's left inside. And y to the 7th, there's 3 sets of twins in there, so I get 144 x cubed, y cubed, and there's one little y left on the inside of it. So that's simplifying with multiplication. I also did one where it's division in here. So let's say we have something like this. 4 over 2, x to the 5th, x to the negative 3, y to the 7th, y squared. And I'm trying to simplify that thing. Well, I know that I've got to take anything that's a negative exponent and shove it upstairs, so I can rewrite this thing now just like this. 4 divided by 2 is 2. If I shove all 3 of those up there, that's x to the 8th. And if I fight these out, because I don't want to shove them up because this is positive, right? 7 of them upstairs, 2 of them downstairs. The upstairs wins by 5. So I get this. Now I'm looking for twins. There's no twin 2, so I can't pull anything out, but I can pull out an x to the 4th, and I can pull out a y squared. Left inside the radical is a 2y. So that's what simplifying radicals look like. Then we'd have to solve some equations. When I solve some equations, it might look something like this. 2 times the square root of x plus 3 minus 4 equals, let's say, 5. Nope, let's make it 6 so that we can have an easier number. So I'm trying to solve this equation for x. Step number 1, I'd add 4 to both sides, add 4 to both sides, and now I get 2 square roots of x plus 3 equals 10. Divide by 2, and I get the square root of x plus 3 equals 5. I can't solve any of these things for x until I've isolated my radical. I've now done that. Now I can square both sides, and I get x plus 3 equals 25. Subtract 3, and x equals 22. So there's solving radicals. Now I could have the same thing when I do something like this. 4x to the 1/3 plus 7 equals, and let's go ahead and do this. Let's say you guys have your calculators, that's fine. We'll go ahead and just put 10 on there. So I subtract 7, and I get 4x to the 1/3 equals 3. divide by 4, and I get x to the 1/3 equals 0.75. And to undo a 1/3, I raise it to the third power, and I raise it to the third power. And x equals 0.75 raised to the third power. Pull out my handy dandy calculator, 0.75 raised to the third, and I get 0.421875, 0.421875. The other way I can think of it, it was 3/4 that I raised to the third power, and that's 27/64. So either of these are fine as a fraction or as a decimal approximation. So those were some of the ones. We had the variation problems, where if I said y varies inversely as x squared, and then y equals 20 when x equals 4. Find x when y equals 800. So I do something like that. So what I have to do first is I have to be able to realize what this thing's saying. So y varies inversely as x squared means I have to write y equals k over x squared. Inversely means that they work opposing. So as one goes up, one goes down. I then take my information, my 20 here, equals k over 4 squared. That's 16. 16 times 20 is 320. So my k equals 320. So then I can go ahead and find x when y is equal to 800. So I write it again. 800 is equal to 320 divided by x squared. So I take my x squared and my 800 and I swap their places, and I get x squared equals 320 over 800. And I pull out my handy dandy calculator and I do 320 divided by 800, enter. And I raise that to the 0.5 power, or the square root of that, and I find out that x equals 0.6324, and that's close enough for me for a problem like that. So that's a variation equation problem, and it could be direct or inverse. So what are some of the other things that you guys have to be able to do on this test? You have to be able to factor, and you have to be able to factor for an understanding. So let's say that I had this one, x squared plus 7x plus 10 over x squared minus 4, something like that. Well, I want to be able to know what's undefined, or I want to be able to simplify this. Well, this becomes x plus 2 times x plus 5 over x plus 2 times x minus 2. Well, the x plus 2 cancels each other, and it simplifies into x plus 5 over x minus 2. But I also know that x cannot equal 2 or negative 2, because those things would give us zeros in the denominator and zeros in the denominator. And the denominator are undefined, not allowed. Division by 0, not possible. Okay, so then I have other ones like this, a little bit bigger, maybe. X squared minus 4 over x squared plus 4x plus 4 divided by, in this case, let's do x squared minus 7x plus 10 over x, let's go x squared plus 5x. So I got something like this. Well, we know that division means copy dot flop. So what I'm going to do is I'm going to copy down the first fraction, except I'm going to go ahead and factor stuff out. So I got x plus 2 and x minus 2. And in the denominator I got x plus 2 and x plus 2. Copy it, change this to a dot, change this to multiplication, and flop this one. So on the top, this x squared plus 5x, or it was on the bottom, now it's going to be on the top. I can pull out an x and get x plus 5. And in the bottom, I'm going to get x minus 2, right, and x minus 5, like that. So then I start knocking off anything that I can. So I got an x plus 2 here, and an x plus 2 here, and an x minus 2 there, and an x minus 2 there. And I don't get to cut anything else off. This looks like it's close. Like if that was x squared minus 5x, then I could knock off those x minus 5s. But I really can't, because that's a plus 5 and that's a minus 5. So then I know in the end it's x times x plus 5 over x plus 2 times x minus 5. That's as simplified as it can go, and I would let you know that x cannot equal any of these things that were in the denominator spots from the original problem. Okay, so I can't have this, right? So I can't have, if the plus 2 is there, I can't have a negative 2. And here I can't have a 0 because I pulled the x out of this bottom right here, and I can't have a negative 5. So those are my 3 places that those aren't allowed. I have stuff like this, 4/7 plus 2/3. Well, that's a fraction adding to a fraction. And we said we did something called crisscross smiley face. So I do criss 12 plus cross 14 over smiley face 21. So that final answer is 36 over 21. And if I can reduce that, I want to be able to reduce that. Oops, sorry, my bad. 26 over 21. And I can't reduce that, so that's the final answer. So if I have letters on there, 2 over x plus 4 over x minus 7, I do the exact same thing, so don't let that freak you out, okay? So that's 2x minus 14 plus 4x over smiley face x squared minus 7x. Simplified, I get 6x minus 14 over x squared minus 7x. And that would be my final answer there. Again, that's adding or subtracting. Now, occasionally we have equations in between here where we're going to solve them. So let's say we had 3x equals 4 over x minus 2. Well, this is a completely different problem. Those were plus signs or minus signs. It doesn't matter, separated by terms. This is an equal sign. When we have an equal sign of a fraction equal to a fraction, we do cross multiply, but we don't smiley face. We cross multiply to solve the equation. So I go here and I get 3x minus 6, and I go here and it equals 4x. Subtract the 3x and I get negative 6 equals 1x, and x is negative 6. Throw it back into the original problem and check to see if it actually works. Now if the equation's a little bit bigger, or it's got some more stuff to it, let's say I have something like this, x squared plus 8x plus 15 over x plus 5 equals 14, and I want to go ahead and solve that equation. Well, what I'm going to do is I'm going to factor the top, and the factoring the top comes out to be x plus 3 and x plus 5, and you can see that x plus 5 kills that x plus 5, and now I've got x plus 3 equals 14. Look at how easy this is. X equals 11, and there's your solution. Don't make this harder than what it needs to be. Reduce any of your fractions that you can before you go any further. Okay? So then we had problems where we were doing stuff like this. 3 times x minus 7 over x squared minus 9x plus 14. And I ask you for VAs and HAs and X ints and Y ints and wholes. And I did one that was 50-50, so 50% of it's factored up here. This one's not factored. So what we're going to do is we're going to kind of write them both out here like this. So I could have completely factored both of these and done 3 times x minus 7 over x minus 2 times x minus 7, like that. And that's in full factored form. Or I could have multiplied this back in at the top and rewrote this as 3x minus 21. over x squared minus 9x plus 14. Well, in either of these two cases, there's certain things that help you get these answers a little bit easier. Okay, so let's go first. I should be able to do, in my original setup, I should be able to do a horizontal asymptote. In this case, the numerator has an x, the denominator has an x squared. X squared is a much more powerful term, so if I have something little divided by something more powerful, or something small divided by something bigger, it's going to get closer and closer to 0. So my horizontal asymptote is at y equals 0. Please don't put 0, put y equals 0. It is an equation of a horizontal line that the graph gets closer and closer to. Okay, the other thing I can do is my y-intercept. My y-intercept is when x equals 0. So I simply plug 0 into this, and 3 times 0 is 0, so I get negative 21. That's my numerator. And then plug 0 into this, and x squared, 0 is 0, and minus 9 times 0 is 0, so I get 14. Negative 21 over 14. Now, if you want to, you can go ahead and reduce that. That becomes negative 3 halves. Or you can leave it just the way it is. All the rest of these three things are found by the factored form. So the first thing I have to do is check. I have to check for holes. If there's a factor upstairs and downstairs that's identical, then there's a hole at the 0 of those two expressions. So 7, positive 7, 7 minus 7 is 0. X equals 7 is a hole because they're identical. If there's no identical factors upstairs and downstairs, then there's no holes, and you put no holes and you move on to the next problem. Now once I've done with the holes, I look for vertical asymptotes, and vertical asymptotes are at the zeros of the denominator. So that means I have a vertical asymptote at x equals 2. Because a positive 2 would get you a 0 there. Now in terms of x-intercepts occur at the zeros of the numerator. Well, those already became a hole, so is there any other x's upstairs? Nope, there's not. So there's no other x-intercepts. If there happen to be, and again, this is a big if there happen to be something like an x plus 3 up here, then I would have an x-intercept at negative 3, 0. If there was an x plus 8, I would have an x-intercept at negative 8, 0. But there wasn't one of those, so we put no. Okay? Final thing on some of these stuff, let me do two more things. So I can have a 4 over an x plus 3 minus 7, and I have this function f of x is equal to this, and I want to know on this function, do I have any vertical asymptotes or any horizontal asymptotes? And of course I do. I have a vertical asymptote at x equals negative 3 because that's what would make this thing undefined, division by 0. I have a horizontal asymptote. If I just looked at this fraction, 4 over x plus 3, we know that the bottom grows faster than the numerator, so that would be 0. However, this minus 7 shifts that entire thing down 7. So I do have a horizontal asymptote at y equals negative 7. Final thing for this was the Cedar Point trip. So let's say that I had a bus that I wanted to rent for our class to be able to go. It was going to cost $1,800. I need 3 chaperones on the bus, so I know that $1,800 is divided by all the people that are on the bus minus the 3 chaperones that are free. And then of course Cedar Point's going to charge me $68 to get in here, so the cost for P will be that, and that is a wrap. Just a second!